So we're going to look at the average value of the function. Okay, and a really good way to frame this is really the average height of a function. So the average value of a function is the average y coordinate of the function, which is the average height. So we're going to change this slightly differently to kind of frame this, because if we want to find the average height of this curved line, it's not that easy to find. I mean, we can kind of estimate somewhere in here. Okay, but the way we're going to do this is slightly different. We're going to take the average height of this function by looking at the area. We're going to take the area of this function, so that black shaded area, and we're going to take that black area and then take that same area and put it into a rectangle. So essentially we're just figure out where we can draw that horizontal line where the area above is equal to the area kind of out here. Okay, and if we can equal those areas, we know that the red area and the black area are equal. And to find the average height of this function, then what we're going to say then is, well, if we can make this area a rectangle, what we can do is we can take the width of that rectangle, okay, take the area, the red area, divide it by the width, and we should get the height, or the other edge of that rectangle. And so that's what we're going to do. We're going to find the average value of this black line, or the average height of that black line, by taking the integral, or finding the area under the curve, taking that black area and rearranging it into a rectangle, and saying that if I divide that rectangle by the width, I'm going to end up with the height. Okay, so that's what we're going to do. So just kind of make these notes a little bit more clear, hopefully. This is my width. Okay, b minus a represents my width, and that will calculate the height, or in other words, the average value of the function. So the average value of function is going to be taking the area divided by the length of the width here, and algebraically, or with calculus, we're going to find the area using the integral, and finding the area using integrals, so we're going to integrate and then divide by the interval width. Okay, so looking at sine x. Okay, I'm going to just quickly draw sine x from 0 to pi. Sine x from 0 to pi looks like that. Okay, if I want to find the average height, it's probably somewhere in here. Okay, and so there's 1. So we know it's got to be somewhere a little bit less than 1. Okay, we're not exactly sure where it is, but if I were to kind of estimate, I might estimate a little bit lower than that. I'm not sure. But if I want to find the average value of that function, what I'm going to do is I'm going to take this area, which is my integral, okay, and then I'm going to rearrange that integral into this rectangular area. Okay, I'm not going to actually physically rearrange it, but I'm going to make the analogy: the yellow area is equal to the red area. And if I divide it by the width, which is pi minus 0, I should get the average height, or in other words, the average value of that black line through that interval. Okay, so this is what I'm going to go ahead and do. So my average value, or in other words, my average height, is going to be the interval width, okay, times the area under the curve in that interval. Okay, so then there's my width. Okay, anti-differentiate that, I'm going to end up with negative cos from 0 to pi. Taking that, work out that area. So cosine of pi is negative 1, minus negative, so plus, cosine of 0 is 1. Okay, so I end up with negative of negative 1, or 1 plus 1 divided by pi. So I'm going to end up with 2 over pi. And the decimal value, I'll just plug that into a calculator here. So as a decimal value, it's going to be about 0.6, somewhere around there. So 2 divided by pi, 0.64. Okay, that seems about right. It's about 2/3 of the way up. Okay, so 0.64 as my average height. Okay, so that makes perfect sense. And this is what we've done. We've taken the area under the curve. Okay, we've taken that area under the curve, this area here. Okay, and we've made it into a rectangular. We've taken that area and essentially make it into a rectangular area, divide by width to give us the height of that graph. So the average value is calculated that way.